Ladies and gentlemen, we had a request to do a roadmap for our test one review. This is the roadmap from winter 2022. T1. And it looks like we're supposed to start right here. We have an alcohol. We have a primary alcohol. Primary alcohols can be made into aldehydes using PCC. Chapter 10, we learned that. Primary alcohols or secondary alcohols can be made into alkyl chlorides using SOCl2 and pyridine. Short form for pyridine is acceptable, PYR. Anything else that's review? That's your two big review items up there. What's going on to get from an aldehyde to an aldehyde with a halogen on the alpha position? That was our last lecture. That was near the end of chapter 16. We learned a method that could put multiple bromines here. That's the one where you had to use base. And we learned the one that you can put a single bromine here. That's the one where you had to use acetic acid. So acetic acid and bromine. Br2ACOH. Alpha bromination. And then what are we doing? Looks like we're doing what's called protection. We're putting an acetal onto an aldehyde. Remember, that is the most important reaction this test. Acetals and hemiacetals from aldehydes and ketones. You got to know you need an aldehyde or a ketone. You got to know you need an acid catalyzed, sulfuric or toluene sulfonic. You got to know excess alcohol. In this case, it's going to be a diol. And it's a condensation reaction. The diol has 3 CH2s between the two alcohols. How do I know that? Well, I looked at the picture of the product. 1, 2, 3. And 1, 2, 3. Excess alcohol. There's 2 alcohols. Good. So we've made an acetal. The reason we did that is because we wanted to make a Grignard and we didn't want it attacking an aldehyde. Yeah, Grignards love attacking aldehydes. If you
do we need to copy anything down?
my computer's doing weird stuff. I hope we didn't lose our connection there. It just went off and on. I'm sorry. Okay, so we're going to attack something. The question is, what did we attack? We attacked an aldehyde or a ketone or an epoxide is the most common things we look at. If you attack an aldehyde or a ketone, you get a new alcohol, and the carbon that got attacked is the new alcohol. That's not this one. How do I know it's not this one? An aldehyde or a ketone was a bad choice because the new bond is right here. Well, I'm trying right there. Thought it was going to be red too.
Dr. Whitaker?
Yes.
You're not sharing your screen right now.
Did that just happen or has it been a while?
It just happened now.
Okay, I'm going to start sharing my screen. Here we go. This came back. That makes sense. And we are now on our Starboard software. And I left off here. So the question is, how do you know what you're attacking with this Grignard? And the answer lies in the product. There's no alcohol on this new bond. That means you attacked an epoxide. There used to be a triangle right here. So that's the answer to that. You need to attack an epoxide that has 1, 2, 3, 4 carbons, epoxide on the end. And always step 2 for either attacking an epoxide or attacking an aldehyde ketone. It's always HCl. You got to get an alcohol. So there we go. And what happened here? It looks like the protecting group got removed. It's called deprotection. Did you remember that the protection was a condensation reaction? Because if you did, then you'll remember the opposite is called hydrolysis, which is half the answer right there. Write water down. You remember what the catalyst was for making the acetal? Because the same catalyst is used to break the acetal, sulfuric acid. We've got our aldehyde back, and this is my favorite part of the test because I get to do hemiacetals and acetals again because I have an alcohol and an aldehyde. They're in the same molecule this time. It's going to be intramolecular. How big will the ring be with the hemiacetal? And how do you know you need a hemiacetal? Shouldn't have to explain that one. Hemiacetal written right there. The O ends up attached to the carbonyl. That's the ends of the ring. 1, 2, 3, 4, 5. Draw a pentagon with an oxygen in a corner. If you're having trouble visualizing, always feel free to use numbers. I'll call the O number 1. I'll try. 2, 3, 4, 5. 1, 2, 3, 4, 5. Now make sure the stuff's on this molecule that was on the other one. Carbon 2 has an ethyl. Carbon 3 has nothing. Carbon 4 has a sec-butyl. Carbon 5 will be a hemiacetal. Right now it is not. Carbon 5 has the ether part of the hemiacetal. It needs the alcohol part. That's the original carbonyl oxygen. It's now an alcohol, and it's about to become water. We make the acetal. This is the easy part. If you've done good work to do the first one, I just want to make sure you know that's a carbon there. If you've done the work to get to here, just get rid of the OH and put the O from the alcohol in its place, and you're done. Yeah, you got to make the second ether. So we got O isopropyl. That's what this is, isopropyl. And finally, a dead end. Yay. Got a dead end. We also got some stray marks here. Save. And we'll go upstairs. Back to our aldehyde. We're going to make another acetal. This time it's a thioacetal. How do I know that? Well, thiols do what alcohols did. Teacher's trying to give us big hints here. There's DST. It's a condensation reaction. Excess alcohol or thiol, sulfuric acid. You're making acetal this time. How do you know the teacher doesn't want the hemiacetal? I didn't ask for it. I only want the hemiacetal if I ask for it. Otherwise, I'm giving you excess alcohol or thiol, and I want you to go straight to the acetal right here. Okay, acetal will have 2 sulfurs attached to this carbon. Copy all the carbons. Copy the 2 sulfurs. How many carbons between they have ethyl groups each? It's not a ring this time. Got to make this look like a carbon here. There we go. So that's a thioacetal. Thioacetal. I think I put it in the wrong box. I apologize about that. Moving it's going to be a nightmare, I am pretty sure. Yeah. Well, that's why we have an eraser. Didn't like the way I drew it in the first place. How's that? And no, stray mark. Fine, I'll live with you. All right, start over. Not start over. Copy the carbons. Sulfur number 1, sulfur number 2, ethyl, ethyl. And now I need to know the chemicals that are going to let me make what bond and get rid of this. There's a lot going on here. Please be able to see that that's the new bond right there. So if I can have a nucleophile here, which I know I can attack an aldehyde. How do you know you're attacking an aldehyde and not an epoxide this time? The alcohol's on the carbon that got attacked. That's aldehyde ketone. When the alcohol is on a carbon adjacent, there's the new bond. The alcohol's on a carbon adjacent. You're attacking an epoxide. I hope we're clear. Okay, we're attacking an aldehyde here in step 2. You can't attack it until you have a nucleophile. This box is not big enough. You need an anion nucleophile to attack. KH, step 1. This is our new pKa right here. This, if I put a red H there, you're going to think that it's related. It's green. pKa 30. KH is plenty. So now you're going to make this bond after you get an anion here in step 1, attack the carbonyl, you get an O- up here. 1, O- needs to become OH. 2, deprotection. They can be accomplished at the same time using the chemicals that are used for the deprotection. It's got an acid in there. Instead of using a catalytic amount, use an excess amount. 1 mole to provide an H for the alcohol that you haven't put on here yet. H2SO4. You don't even have to write excess. I don't mind. Just write H2SO4 and water. If you want, because you're used to step 2 every time being HCl or being HCl when we did it, didn't we do another one? HCl somewhere else, magnesium, HCl. We attacked an aldehyde earlier. This is the aldehyde. You could write HCl as step 2, and then you got to do step 3, H2SO4 and water. I have no problem with it. Okay, you're kind of you don't need a separate HCl step when you're adding this acid. So that's that. Good synthesis. Now it's about redox. Do you know how to reduce a ketone to an alcohol? That's question 1. Question 2, do you know how to oxidize an alcohol to a ketone? Both will be on every test without exception this semester. So reduction of ketones to alcohols, we learned that. That's pretty new. One nice way was NaBH4 followed by HCl. You could have used H2 platinum and pressure instead. Now the oxidation would be PCC. You could have used the other chromiums here as well. K2Cr2O7 sulfuric acid and water gives the same result as CrO3, H2SO4 and water. Any of those three answers goes in that box because it's a secondary alcohol. All chromiums result in ketones. Okay, so where are we at now? We're at a diketone. Since we're doing that, we're going to use an excess of a primary amine. Each primary amine will condense. Look, DST, you knew it was condensation anyway. Each primary amine will condense with a ketone to make an imine. Two imines because we have excess amine. Copying the carbon skeleton. Don't copy those oxygens, they're gone. Condensation, got rid of them. These are propyl groups on the nitrogen. There you go. And that is making imines, and then we're going to reduce our imine to an amine. Okay. So reduction, H2 excess, you're going to reduce both pi's and put H's on both sides of the pie. You're going to get amines. Amines. Must show the H on the end. Don't have to show the new H on the C. Stick figures took care of that. That's not a propyl. There we go. That looks like a 2, doesn't it? I don't know. Look more like a propyl now. And now what's going on here is both amines are secondary and they became enamines. What chemicals are needed to make a secondary amine into an enamine? Well, what chemicals were needed to make an imine? A primary amine and an aldehyde or a ketone. Secondary amines with aldehydes or ketones give enamines. Enamines. I misspoke. Enamines. Enamine. Enamine. We need a molecule that's here. The carbonyls are where the nitrogens ended up attached. They did not have pi bonds between carbons. They used to be ketone right here. So I'm just going to throw DST in here because it's another condensation. You do not have to show me DST. And just make sure you got all the carbons you need. There you go. It's not very well drawn. It's supposed to be an oxygen. There we go. So it's a symmetrical diketone. If you're having trouble seeing it, it should be symmetrical. All the carbons are 1, 2, 3, 4, 5, 6, 7, 8. 3, 6, 7, 8. Yeah. And then we're going to reduce that. So pretty much those pi bonds are going to be gone. Everything else you see is copied. And merge. There we go. So there's no pi, and that's a reduced amine. Process is called reductive amination. We did it twice. Reductive amination number 1 to get to these amines. Reductive amination number 2 to get to these amines. And the dead end. Let's pick up where we left off. We didn't go anywhere from here. How do you make an alkyl chloride into an organolithium? Well, same way you made the Grignard, except use a different metal, lithium, and a different solvent, in this case, hexane. No ether solvents necessary for organolithium synthesis. I see a synthesis step here where there's a new bond from here to here. And at the end of that new bond is an alcohol, indicating you needed to attack an aldehyde or a ketone. When there's an H on that carbon, it's an aldehyde. If there was no H, it would have been a ketone. Here is the carbon. That's step one. What's step two? Almost always HCl. Made a new bond. Pretty exciting. Oh my goodness. If we don't know the oxidation of alcohols to ketones on our tests and the reduction of ketones to alcohols on our tests, we're throwing away probably 10 points. We've already done this reaction. Let's do it again. Alcohol became carbonyl right there, PCC. Alcohol becoming carbonyl, PCC. What do you get with a secondary amine and a ketone? Ketone, primary amine gives imine. Ketone, secondary amine gives enamine. Let's put an enamine, and there's a major and a minor, remembering that the double bonds can go either here or here, and the latter one is more substituted. 2 carbons on the end. Better double bond there. That's major. So you're going to get a double bond here, and the nitrogen there, and it comes up to, and similarly, yeah, and double bonds up here this time. There you go. So major has the more substituted double bond. Minor has the less substituted double bond. How do you know where the double bonds can go? You can't just randomly put them where you want. They have to be, one of the positions of the double bond has to be the original carbonyl. Both molecules have the original carbonyl carbon is part of the double bond. There and there. I think we may have had a question in there. Nope, just an accidental microphone. Now, why react minor only? I didn't even need to say this, everybody. I just did that so you didn't think too much. If you react either one of these with H2 and PT, you will get the same result. So I didn't need to say this. But let's just look at the minor and get rid of the double bond and be done with this guy right here. Okay, here we are. And we got an N. I think we have everything we need there. Yeah. Double bond's gone. Got an L. Got an amine, tertiary amine. Another dead end. All right, we didn't finish going this way. Let's see, organolithium becoming a, oh yeah, that's a Gilman. How do we make a Gilman? Now, some students just leave this thing blank. They say, I forgot. I mean, there's enough information to try to get partial credit. There's a new element in there. Why don't you copy that in the box? There's copper. It wasn't there before. You're going to need copper. And for those of you who can vaguely recall Dr. Whitaker saying this is not redox. It was redox to make the organolithium. It wasn't redox to do this. So copper metal is not a good choice. And if you think about it, that's 2 carbons with a minus attached to a copper, and only 1 plus to balance that. So I have 2 minuses and only 1 plus to balance. I need another plus. I need copper plus 1. Hey, I probably give you full credit if you even acknowledge that. Technically, I shouldn't, because it should be this copper, because not any copper plus one works. But copper iodide, cuprous iodide is what they call it. That is the chemical that makes your Gilman. And then you got to realize Gilmans can undergo coupling reactions with organic halides. And it is the easiest reaction of the semester. What's in the parenthesis? You take the carbon attached to copper and attach it to the carbon that used to be attached to the iodine, and the copper and the iodine are gone. So I'm going to copy the alkene without the iodine. New bond to the carbon that used to be bonded to the copper. So 1, 2, 3, 4, 5 in a row. 1, 2, 3, 4, 5 with a methyl. The second last one. There you go. Yep, double bond has the same geometry I had before. And it's coupled. So Gilmans are good for coupling. What else? We had a dead end. We got to the diol here and we didn't do anything with it. That's our finishing salvo, as they say. I don't like that word. Okay. All right. NaBH4 HCl. We got a diol. Oh man. A vicinal diol. Now this is, I would consider this like a bonus going to here. These two guys. Because that's review. You do see that water was lost, right? It's dehydration. If you can remember the chemical and the conditions where dehydration happens, you get full credit. It's a special dehydration because there was a rearrangement, but that doesn't matter. Dehydration of alcohols is H2SO4 and heat, the opposite of hydration of an alkene, which would make a diol or an alcohol. Okay, so you remember that you make one of these leave, you get a cation, and then an H can move from here, and you get a ketone there. Or this can leave, you get a cation, and H moves from there, you get a ketone. I think I just talked about the same one twice. But they both do the same thing and get these two ketones. And now we're into ketones. Doesn't matter if that was a review reaction. We have ketones. We're supposed to know what they do in chapter 16. So ketones react with Grignards. Ketones react with organolithiums. They do exactly the same thing with each. So groovy. We're getting same points for doing each. Let's do the one on the right first because it doesn't have a D protection mixed in too. The one on the right, I need a new bond from the carbon with a lithium to the carbonyl. Original carbons on top here. You get an OH. You get your new bond. To a carbon, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 with a methyl on the second last one. There you go. Exciting, exciting, exciting. All right, now I have an alcohol, and here's an acetal. I have an alcohol, and here's an acetal. What are all the parts necessary to make an acetal? Alcohol is 1/3. Another alcohol is the other third. Yes. And a carbonyl, either ketone or aldehyde. How do you know which carbon used to be the ketone or aldehyde? The one that has 2 bonds to O in the product is the one that had 2 bonds to O before it got attacked. There's your 2 bonds to O. There's your black dots. That piece came from here. You have one alcohol to do that with. You need the second alcohol. What does it look like? Methanol. So CH3OH. What's the catalyst? Sulfuric acid or HOTS? I need all three things in there. 2 alcohols, carbonyl, acetal. All right, now this one's bringing in an acetal with it. So what I'm going to do is draw everything you get in step 1 right now. Okay. Step 1 only. I will be having my eraser ready. So you're going to get an OH. You got a new bond up here. I don't have much room up there. Yeah. I don't think I'll be able to move my molecule. No. Meanie. Red pen. New bond here to carbon that has the thing to the right, thing to the left with a methyl and an ethyl. Now, the thing to the right, I'm not going to draw. The thing to the right, what do I got? I drew this bond here from there to the carbonyl here. Oh, I erased things. To the carbonyl here. It became an alcohol. Wow. Over to the right of this bond is this bond here. It will be this acetal. Step 2 gets rid of the acetal because not only did it protonate the alcohol you just made, but it deprotected the acetal. So I just want to remind you, the alcohols that used to be part of the acetal, I'm not really giving credit for them. They're over here. It's the protecting group. And this used to be a carbonyl. Here it is. I'm trying. I will make sure you know. This was a 1 carbon here. That's this carbon here. Okay? Has 2 bonds to O. Has 2 bonds to O. Used to be 2 bonds to the sigma bonds to the alcohol in the acetal. Now it's 2 in a carbonyl. Okay. There you go. And what's going on here? Well, there's a lot going on here. I see my aldehyde. You see it? Another clue that it should have been aldehyde. I see the O here still, but that O is now tied up with another protecting group. And this is the DHP protecting group we talked about in class the other day. And that is the easiest protecting group to put on alcohols. Use dihydropyran and sulfuric acid. And you get this. Now you can do Grignard chemistry here without worrying about your alcohol losing its H. That's why I did it. This Grignard is a powerful base. It would take the H off of an alcohol and you'd be destroyed. So what's the Grignard going to attack here? Carbonyl. You're going to put an ethyl up there. You're going to get an O- up there. You're going to get rid of your protecting group and get your alcohol back. And then we'll talk about what happens with this aldehyde later. Because we're going to have alcohol. And yeah. I don't know if we're going to see what we're going to do here. Okay. Blue, big finish. That'd be an OH. Here's your new bond. It's pretty exciting. Here's your new ethyl group. And we're up to here. We got our new bond. We're coming down from the alpha position. I don't think I did that right, did I? Yeah, methyl, C, yeah, alcohol. So there. I'm doing something wrong. I'm not liking what I'm doing. Sometimes a teacher needs a break too, you know. Here we go. There's your OH. Here's your new bond. Here's your ethyl. Okay, so I've got that carbon done. I got to go to the alpha position and draw a bond down. That's where I screwed up. And then that's got a propyl. That's got a 2-methyl butyl. 1, 2, 3, 4. Yeah. It's got an acetal. There you go. But that's not the final result because we didn't deprotect this. So what would happen there is this. I'm just going to show you. Water and sulfuric acid is deprotection of acetals. Sorry about getting rid of that beautiful quote. Try to do minimal damage there. Okay. So now you're going to get your alcohol back. And then remember that alcohols will react with aldehydes or ketones. Especially if there's 2 alcohols. To make what? Most important reaction in this chapter? Acetal. So what do? I don't want to start over. I'm not. I'm going to get rid of the H's because they attacked the carbonyl at 2 separate times. And I'm going to do it all in orange and it's going to look weird. But there's a bond from this O and this O to the same C. And that C is this C right here. It's an aldehyde. Got an ethyl on it too. There you go. And there's your final product. It's an acetal. There's the acetal carbon right there. And wow, that was epic. No blanks. Any questions? Cool. Now, before I let you go on this video, I want to have you guys tell me what you want for the next video, and I'll have that set up when we get back. So what are we going to do in our next video? Oh. I'm going to end the meeting. No ideas for the next video? That's an early day. I'm okay with that.
Can we do the last question on test 1, winter 22?
Winter 22, last question, test 1. We'll do that next. All right. See you soon.